In this lesson, we're going to verify inverse functions algebraically. And given a function f of x, we can verify whether another function g of x is the inverse of f of x by checking these two conditions. And you must check, notice there's an and there, so you must check those two conditions. So the first is that and you're dealing with composition, so when you take g of f of x, you're going to get x back, and when you take of f of g of x, you get x back. So remember in previous lessons that inverse functions undo each other. So if you take x and substitute f, and then take that, substitute g, if they're inverses, then you'll get x back. Same thing here. If you take x, any value of x that's in the domain, and you substitute into g, you find out what y is here, what g of x is, and you take that value, put it in its inverse, then they're going to undo each other, and you'll get x back. All right? So when determining algebraically whether two functions are inverse of each other, you must do these two things. You must show those two things. You must show that g of f of x is equal to x, and f of g of x is equal to x. All right, so the steps would be that first thing you would do is you would calculate f of g of x. So you do this, then you calculate g of f of x, and then you're going to verify that both of those are equal to x. And if that's the case, then they are inverses of each other. F of x and g of x are inverses of each other. Note that if either of these are not equal to x, so if one is and the other one isn't, then you must say that those are not inverses of each other. I'm going to say this. Generally, if one of those is equal to x, then the other one will be equal to x as well. All right, usually that is the case. But there are some situations, especially with square roots, where that is not always necessarily true. So that's why you must do both of those. You must check both. All right, now in the assignments, you'll if one's equal to x and the other one's equal to x as well. So you will have to check both, though, if you want all points. Don't just check one. You must check both. You must check both conditions. You must do step 1, step 2, and then verify that they're both equal to x. Okay? It's not a difficult process. It's a fairly simple idea, and algebraically, the steps are easy to deal with. We're going to start with a very simple one. So these are both linear functions. So f of x is equal to x minus 7, and g of x is equal to x plus 7 divided by 2. Now remember, inverse functions undo each other, right? So you can tell that these are inverses. You know that those are inverses because if you look at this, f of x takes x, multiplies it by 2, and then subtracts 7. Its inverse will take x, add 7, because remember, do the opposite. Subtracting 7, the opposite is to add 7. And then right here, you're multiplying, the opposite is to divide. All right, so you know they're inverses, but you must do this algebraically. All right, so let's look at how to do that. So step one, you're going to find f of g of x. Okay, you're going to do that first. And you want to make sure that's equal to x. All right, so you want that to be equal to x. So so if you take g of x, put it back into f of x, you want to get x back. You want f and g, when they're inverses, f and g undo each other, and you get that x value back. Okay. So first thing you do is you're going to determine first of all what is g of x. Well, g of x is this. You're going to take this g of x, you're going to substitute it here. So this becomes f of x plus 7 divided by 2. All right, so remember g of x is this. Then you're going to take this right here and you're going to substitute into your function g. I'm sorry, your function f. And so remember f of x is this, and we're going to rewrite it. All right, and in place of x, you're going to substitute g of x, which is x plus 7 divided by 2. So this becomes 2 times x plus 7 divided by 2 minus 7. And then simplifying this, the 2's divide out, and so you get x plus 7 minus 7, which equals x. So therefore, f of g of x is equal to x. All right, so that's step one. So you found that when you compose, remember these are compositions. So remember that's the same thing as saying f composed with g at x. All right, so you just found that when you compose f and g, so when you take f of g of x, you get x back. All right, but remember, if you want all points, generally, if one's equal to x, then the other one's going to be also. But if you want all points, you will need to show both of those. So step 2 is to find now g of f of x. Okay, find that now. All right, so let's do the work. So f of x we know is 2x minus 7. So it becomes g of 2x minus 7. And now I'm going to go to my function g, and wherever I see the variable x, I'm going to substitute 2x minus 7. So remember, this is g right here. So I'm going to go ahead and write it over. G of x is x plus 7 divided by 2. So in place of this x right here, you're going to substitute 2x minus 7. So this becomes 2x minus 7 plus this 7. So remember remember this is x right here, right? So this right here, I substitute to x. And then this plus 7 is this plus 7, and then divided by 2. Combining like terms, a negative 7 plus 7 is 0, so you get 2x divided by 2, which is x. So therefore, g of f of x is equal to x. And then finally, we can say this in step 3. Remember, step 3 is to compare them and make sure that they're both equal to x. So step 3 is since f of g of x is the same as g of f of x, which equals x, then f of x and g of x are inverses of each other. They undo each other. Inverse functions undo each other. So inverses of each other. Okay? All right. So that was number 1. It's not a difficult process or idea. You just have to remember that if you want to determine algebraically whether two functions are inverse of each other, you are going to have to find f of g of x and g of f of x and check and make sure that they're both equal to x. All right, now generally, if one's equal to x, the other one's equal to x as well, but there are some situations where when you're dealing with square roots, where depending on the domain and range, if they're not compatible, if the domain and range are not compatible, they're not going to be able to both be equal to x. All right, so that's the only situation. But in our cases, if they're inverse of each other, then both of these will both be equal to x. All right, so if one is equal to x, and the other will be equal to x. All right, that's number 1. Let's look at number 2. All right, here's number 2. So determine algebraically if f of x, and they're both linear functions, so linear function is always the easiest to deal with. Determine algebraically if f of x, which is equal to negative 8x minus 7, and g of x, which is negative x divided by 8 minus 7 divided by 8, are inverse of each other. Okay, so remember step 1, you have to find f of g of x. All right, and you want to see if that's going to equal x. All right, so you want to find this first. All right, so g of x is this function right here, right? So I'm going to put this expression into g of x. So this becomes f of negative x divided by 8 minus 7 divided by 8. Okay, so remember that's g of x. You see it right here. Then I'm going to take this right here and I'm going to substitute to the function f, where we see the variable x. So remember f of x is this. It's negative 8x minus 7. So in place of the variable x right here, I'm going to substitute this expression. So this becomes negative 8 times, put that in parentheses or in brackets, negative x divided by 8 minus 7 divided by 8, and then minus the 7. So remember negative 8x, this is x right here, So negative 8x, which I'm substituting this, minus 7. Distributing, I get negative 8 times negative x divided by 8 minus negative 8 times 7 divided by 8, right? Subtract right here. This part here is this. So times the negative 8 times that. So the 8's divide out right here. So you get negative 1 times x times a negative x, which is a positive x. And then 8 and then 1 here. So you're subtracting a negative 1 times 7. So that means you're adding the opposite. So it becomes plus 7 here. Oops, and don't forget I forgot to subtract 7. And then subtract 7. And then the 7's cancel out. And so you're left with x. So therefore, f of g of x is equal to x. All right, step 2, remember you can't do step 1. So generally though, if one's equal to x and the other one will also. All right, but you gotta show that. You gotta show both. Remember that's an and here. All right, that's an and. It's an and. You must show both because there are mathematically there are situations where one of those will not be equal to x. All right, so just keep that in mind. So that's why you must show both if you want all the points. Step 2, you want to find g of f of x. So let's find f of x. So f of x, remember, is this function right here, negative 8x minus 8. So I'm going to write this as g of negative 8x minus 7, excuse me, negative 8x minus 7. And remember that's f of x, right? So now I'm going to take this, substitute my function g. So remember g of x is this right here. So it's negative x divided by 8 minus 7 divided by 8. All right? So that's minus 7 divided by 8. So in place of this x right here, now you got to be careful because this says you're taking the opposite of that, so you got to be careful. So in place of this x right here, I'm going to substitute that expression. But when you rewrite it, you got to be careful. You're gonna take what you're gonna put here in parentheses because you're taking the opposite of all that. So you're gonna have to write it like this. You have to say in parentheses the opposite of negative 8x minus 7 divided by 8. So notice this right here is this, the opposite of what I'm gonna substitute. I'm substituting to this right here, and then minus 7/8. So that becomes, now you're gonna distribute. So the opposite of a negative 8x minus 7 is 8x plus 7 divided by 8 minus 7 divided by 8, right? Since the denominators are the same, I can write this as 8x plus 7 minus 7 divided by 8. These 7's add up to be 0, so I get 8x divided by 8, which is just x. So therefore, g of f of x is equal to x. Now I can make this statement. Since this composition, f of g of x, step 3, since f of g of x is the same as g of f of x, which is x, then f of x and g of x are inverses of each other. Oops. Okay, so since f of g of x and g of f of x are both equal to x, so they undo each other. Remember, the inverses undo each other. So that's why you get that x back. Then f of x and g of x are inverses of each other. All right, so that's number 2. Now, numbers 1 and 2, those were both linear functions. So those inverses were linear functions. Let's look at this one. Okay, so number 3, you want to determine algebraically that f of x, which is this cubic function, see this cubic function, and g of x, which is a cube root function here, are inverse of each other. All right, so remember you got to show. Remember, if you're going to show they're inverse of each other, you got to show that those two things. Step 1, you must show. You got to find f of g of x and show that that's equal to x. Okay, so let's find that. So you want to make sure that's equal to x. So g of x. So if they're inverse of each other, if you're told they're inverse of each other, then they undo each other. So you get x back. So you get this variable back in both cases. Okay. So g of x is this right here. So be a little bit careful because there's there's a cube root symbol here that you got to be careful of, and here you have a cubing symbol here as well. So just be careful when you write this. So this will be f of, and in place of g of x, I'm going to substitute what g of x equals. So g of x is the cube root of x plus 1 minus 6. Okay? Now I'm going to take this right here and I'm going to substitute it into the variable x in the function f. So that's this right here. So I'm going to go ahead and rewrite this over. F of x is x plus 6 cubed minus 1. So in place of this variable right here, in place of this right here, I'm going to substitute this whole thing. Okay, don't let that throw you off. It's not that bad. Substitute this right here. So in place of this, I'm going to substitute this. So this becomes parentheses. Okay, now I'm going to take what I have boxed in the box, which is x. I'm going to substitute this expression. So that's the cube root of x plus 1 minus 6. And okay, see this right here is now in here. Plus this 6, whatever that is, I'm going to cube it and I'm going to subtract 1. Okay? A negative 6 plus 6, combining like terms, that's 0. So I get, in parentheses, the cube root of x plus 1 cubed minus 1. And remember, cube and cube root undo each other. So you get x, you get the radicand here, x plus 1. So you get x plus 1 minus 1. A positive 1, negative 1 is 0, so this becomes just x. So therefore, f of g of x is equal to x. All right? So far it looks like they're inverse of each other, right? But you got to do the other one as well. So step 2, you have to find g of f of x. You have to do the same thing. Okay, so in this case, I'm going to find f of x, which is this right here. See right here? So that becomes g of, so f of x is this function right here. So I'm going to put that expression in there, x plus 6 cubed minus 1. Okay? Now, I'm going to take this right here, I'm going to put it into my function g where we see the variable x. So remember, this is g right here, so I'm going to rewrite it over. G of x is the cube root of x plus 1 minus 6. So in place of this variable right here, right there, I'm going to take all of this, I'm going to put it right here. Okay? So that becomes the cube root. Now in place of this x right here, I'm going to substitute all this. So it'll be x plus 6 cubed minus 1. So remember, this right here is this x. Right here, the thing I have circled. So that's what I have circled, but remember, I've got to add 1, and then we subtract 6. Now, combining like terms, I want you to know that the negative 1 plus 1 is 0, so this becomes the cube root of x plus 6 cubed, right, minus 6. But remember, the cube root and the cube undo each other, so you get x plus 6 minus 6, and 6 and a negative 6 is 0, so you just get x. So therefore, g of f of x is equal to x. All right. So since f of g of x is equal to x, and g of f of x is also equal to x, so step 3, since f of g of x is equal to x, and g of f of x is equal to x, then f of x and g of x are inverses of each other. Okay? All right, so that was number 3. It is not difficult at all. It's just the same process over and over again. All right, here's number 4. So number 4, determine algebraically if f of x, which is this rational function, x plus 3, 1 over x plus 3, and g of x, which is also this rational function, 1 over x minus 3, are inverses of each other. So if you're going to determine if two functions are inverse of each other algebraically, you have to do those 2 steps that I showed you. So step 1, you have to find if f of g of x will equal x. You want to see if that's going to equal x. So let's find f of g of x. So remember, you gotta check to make sure that this is equal to x and this is equal to x. All right, so in place of g of x, which is this, I'm going to substitute this right here. So this becomes f of 1 over x minus 3. So g of x is this. Now you got to take this right here now and put into your function f where we see the variable x. So remember, this is your function f of x. All right, I'm going to circle the variable x. Wherever we see the variable x, I'm going to circle it, and wherever I see that circle, I'm going to substitute that expression. So this becomes 1 divided by, I'm going to substitute this now, 1 over x minus 3. So remember that's that circle. That's that circle, but remember I'm adding 3 to that circle as well, that x. And then combining like terms, I want you to notice that negative 3 plus 3 is 0, so this becomes 1 over 1 divided by x. See, 1 divided by 1, and then the denominator is 1 over x. Well, remember, when dividing fractions, you take the fraction that's in the numerator, which is 1, times the reciprocal of the denominator. The reciprocal of 1 over x is x, and 1 times x is x. So therefore, f of g of x is equal to x. Okay? And then, now remember, generally, when one's equal to x, the other one will as well. But you have to do both if you want all your points. All right, step 2. Let's find g of f of x. All right, so g of f of x. All right, now, f of x is this function right here, 1 divided by x plus 3. So that becomes g of 1 divided by x plus 3. Okay? So I'm going to take this right here, and wherever I see I'm going to go to my function g, and wherever I see the variable x, I'm going to substitute this right here. So remember, g of x is this function, 1 over x minus 3. So notice I see the variable x right here. So I'm circling it, and I'm going to replace that with that I have circled with this expression. So this becomes 1 divided by, and then x becomes this right here. Now be careful, it's this fraction, right? So it looks like this, 1 divided by x plus 3. So this one is this one, and then this circle is this right here, which is this right here. But don't forget, you're subtracting 3, so don't forget to do that. So subtract 3. Okay, now remember, look at this right here. I'm dividing two fractions. You're dividing two fractions. So remember from previous courses, when you divide two fractions, you take the fraction in the numerator, which is 1 here, times the reciprocal of the denominator. Well, the reciprocal of the denominator, 1 divided by x plus 3, is x plus 3. And then don't forget to subtract 3. Well, 1 times x plus 3 is x plus 3, and then subtract 3. Those 3's add up to be 0, so that's just left with x. So therefore, g of f of x is equal to x. And I want you to notice that in step 1, f of g of x and g of f of x in step 2 are both equal to x. So now we can say this. Step 3, since f of g of x and g of f of x both equal x, this means that f of x and g of x are inverses of each other. Okay? And you see, it's not a difficult process. There's some algebra you have to do, but you're at the level where you can easily do this. You have enough background knowledge, enough prerequisite skills to be able to manipulate these expressions. All right, but remember, when determining whether two functions are inverses of each other, you are going to have to show that remember, you're dealing with compositions. You are going to have to show that f composed with g at x, or f of g of x, is equal to x, and you have to show that g composed with f at x, or g of f of x, is equal to x as well. Okay? All right, let's look at another one. So let's look at number 5. Okay, so in number 5, you want to determine algebraically if these two functions, and those are rational functions. It's a little bit more complicated than the two rational functions we had here. This was much easier to manipulate. This one's not going to be as easy, but you have enough prerequisite skills, enough background knowledge to be able to do that. But you do want to show that these two functions are inverses of each other. So remember, when determining whether two functions are inverse of each other, you have to show those two steps. So step one, you have to show that f of g of x is equal to x, right? You must show that. So we got to find, so we have to find f of g of x. So again, that's one of the things you must show. So g of x is this right here. Now don't let that scare you off. It looks complicated, but it's not. All right, you can deal with this. So remember, that's g of x. So in place of g of x, I'm going to substitute this right here. So it becomes f of negative 4x minus 2 divided by negative 5x plus 3. Okay, so remember, that's g of x, right? So that's all I did. Now I'm going to take this right here, and I'm going to go to my function f, and where we see the variable, I'm going to substitute that. So let me go ahead and rewrite that function over. So here's my function f, negative 3x minus 2 divided by negative 5x plus 4. Now remember, wherever I see the variable x, and I see it here, so be careful, don't let that scare you off. You can do this. I see it here, and I see it here. So in place of those two variables, those two x's I have circled, I'm going to substitute that expression into both of those. Okay, so look at what we get. We get negative 3 times, all right, now you got to be careful. So remember, negative 3 is going to be multiplied by this fraction right here. So put that in parentheses just like this, just like I'm doing. Okay, negative 5x plus 3. So negative 3 times that x I have circled, which is this right here. See that? Okay, minus 2, subtract 2, all divided by, and do the same thing here. Negative 5 times, in place of this variable x that I have circled, I'm going to substitute this fraction right here. Negative 4x minus 2 divided by negative 5x plus 3. And then I'm going to add 4 to that. Okay, now remember, you need to get rid of the parentheses. All right, let's do that first. All right, now listen carefully to what I'm saying. You think of this negative 3 as negative 3 divided by 1. All right, so I'm gonna write that here. So I'm gonna go to another sheet of paper. I'm gonna tell you what that means visually. So you see this right here. See this right here. So think of this as negative 3 divided by 1 times negative 4x minus 2 divided by negative 5x plus 3. Okay, just like that. And now you're going to distribute. So remember, you multiply the numerators together, multiply the denominators together. So I want you to notice that this right here, negative 3 times negative 4x is 12x, and then negative 3 times a negative 2 is a positive 6, divided by, and then 1 times negative 5x plus 3 is negative 5x plus 3. Okay, so that's important you see that. Okay, so this right here is this. Okay, all right, so that becomes 12x plus 6 divided by negative 5x plus 3. So that is this. Subtract 2. Divided by, and then do the same thing here. So let's look at that one. So this right here is negative 5 divided by 1 times negative 4x minus 2 divided by negative 5x plus 3. Just like that. So this right here is the same thing as this. Distributing, I get negative 5 times negative 4x is a 20x, and then negative 5 times a negative 2 is a positive 10. Divided by 1 times negative 5x is a negative 5x, 1 times 3 is 3. So this expression right here is this. So I'm going to replace this with this now, okay? All right, so that becomes 20x plus 10 divided by negative 5x plus 3, but don't forget you're adding 4. Okay, now look at where we're at next. Okay, so this is important. So notice I'm doing a lot of work on this side. That's important you see this. Doing a lot of work on this other side here. Okay, Now, remember, let's go ahead and cover up this denominator here. So I have this right here. So remember, 12x plus 6 divided by negative 5x plus 3 minus 2. I'm going to put this as 2 over 1. When you add or subtract two rational expressions, you got to find the LCD. Remember that? The LCD. Okay. So one of the things, well, let's do it this way. So remember when in a previous lesson or a previous course, you talked about complex fractions. So it might be easier to do it this way. So let me show you this. So I'm going to go ahead and write this over right here. 12x plus 6 divided by negative 5x plus 3 minus 2 divided by 20x plus 10 divided by negative 5x plus 3 plus 4. Okay. So I want you to notice, I'm going to put this over 1, this over 1. So we're going to simplify this complex fraction by multiplying both numerator and denominator by the LCD. So if you look at all these denominators right here in all parts, negative 5x plus 3, 1, negative 5x plus 3, 1, the LCD is negative 5x plus 3. So I'm going to multiply both numerator and denominator by that LCD, negative 5x plus 3. Okay? And I'm going to distribute. All right. When I distribute, I get this. This becomes negative 5x plus 3 times 12x plus 6 divided by negative 5x plus 3 minus 2 times negative 5x plus 3. So this times this is this. This times this is this. These, and let's come back and do that later. And then divided by, and then do the same thing here. So it's a lot of work you have to do, right? But you can do this because you have enough knowledge from previous courses to do this. So we can do the same thing here. So this times this first fraction, so negative 5x plus 3 times 20x plus 10 divided by negative 5x plus 3 plus 4 times negative 5x plus 3. All right, now let's simplify this. So remember, the whole point of multiplying this and this by the LCD is to get rid of those denominators. And so I can do that now. So these divide out. See, those divide out. And then I want you to notice what you see. I have 1 times 12x plus 6 is 12x plus 6. And then let's go ahead and distribute the negative 2. Negative 2 times negative 5 is a positive 10x. Negative 2 times negative 5x, positive 10x. And then negative 2 times a positive 3 is a negative 6. All divided by, and then over here, 1 times 20x plus 10 is 20x plus 10. And then distribute the 4. I get 4 times negative 5x is a negative 20x. And then 4 times 3 is 12. Combining like terms, I want you to notice something. The 6 cancel out here. 6 and negative 6, that's 0. 12x and 10x is 22x. Over here, the 20x and negative 20x is 0. 10 and 12 is 22. Look, we're done. 22 divided by 22 is 1, so you just get x. All right? So, a lot of work. So what we found is this. Now we'll go ahead and simplify this right here. So this part I'm going to rewrite. So I'm going to rewrite this as this right here. So we get, let's see where I was. We get this right here. So this will be 12x plus 6, 12x plus 6 minus 2 times negative 5x plus 3. So I don't want to have to rewrite all this over, so I'm just going to do this. And then this right here was 20x plus 10 plus 4 times negative 5x plus 3. Remember that? See this right here, 20x plus 10 times that. And then when you distribute, you get 12x plus 6 minus, and then negative 2 times negative 5x is 10x. And then negative 2 times 3 is negative 6 divided by, and then 20x plus 10. and then 4 times negative 5x is negative 20x, and then 4 times 3 is 12. Combining like terms, 6 and negative 6 is 0, 12x and 10x is 22x, and 20x and negative 20x is 0, 10 and 12 is 22, and when you reduce, you get x. So therefore, a lot of work, I know, a lot of work, f of g of x is equal to x. All right. Now, you're going to have to do that for the other one as well. So look at all the work you had to do. All right, but you got to remember some things about complex fractions from a previous course in order to go through this. All right, so let's do step 2 now. So that was step 1. So step 2, we're going to need another sheet of paper, right? I know it's not fun. This one's not fun. All right, so step 2, I've got to now show that g of f of x is equal to x. We've got to show that. Well, let's find g of f of x. Okay, so remember f of x is this right here. So this becomes g of negative 3x minus 2 divided by negative 5x plus 4. Right? And then I'm going to do my function g, which is here. So I'm going to go ahead and rewrite it over. Negative 4x, this is g of x, negative 4x minus 2 divided by negative 5x plus 3. And in place of this x, there are two of them. One's in the numerator, one's in the denominator. In place of those x's I have circled, I'm going to substitute this expression right here. All right, and then notice we have a lot of work we have to do. Okay, so let's go ahead and do that work. So we get negative 4 times this fraction. So negative 3x minus 2 divided by negative 5x plus 4. And then subtract 2. All that's being divided by, and the same thing here, negative 5 times, I'm substituting this into here, so we same thing as this one. Negative 3x minus 2 divided by negative 5x plus 4. And then plus 3 right here. Okay? Now remember, I'm gonna multiply this out. So remember, just as in the previous one, you have to understand what you have there. Okay? So you have to understand that this part right here means this. Okay? Negative 3x minus 2, and the denominator is negative 5x plus 4. You have to understand that. So to multiply these two fractions, we're going to distribute the negative 4 here and 1 here. So this becomes negative 4 times negative 3x is 12x. Negative 4 times the negative 2 is a positive 8, divided by, and then over here, 1 times negative 5x is negative 5x, and 1 times 4 is 4. So that right here is this. Okay? So I'm going to take this right here, I'm going to rewrite it as 12x plus 8 divided by negative 5x plus 4, and then minus 2. Okay? All that's being divided by, you do the same thing here. But remember, you're going to take negative 5, you multiply by this numerator right here. Because remember why that's the case. So remember, negative 5 divided by 1 times this fraction right here. Negative 3x minus 2 divided by negative 5x plus 4. Okay? And then distribute and distribute. So you get negative 5 times negative 3x is 15x. Negative 5 times a negative 2 is a positive 10, divided by, and then negative 5x plus 4. So that part here is this. I'm going to replace this right here with this. Okay? So that becomes 15x plus 10 divided by negative 5x plus 4, and then plus 3. Okay, now this is where you're going to look at this as a complex fraction. So my LCD is negative 5x plus 4. So what you're going to do now, I'm going to go ahead and rewrite this over just so you can see this. 12x plus 8 divided by negative 5x plus 4 minus 2, and then 15x plus 10 divided by negative 5x plus 4 plus 3. So I'm going to take both of those numerators and denominators, and I'm going to multiply by the LCD, which is negative 5x plus 4. So times negative 5x plus 4 times negative 5x plus 4. And then we're going to distribute. Okay? We're going to distribute. So when I distribute, I get negative 5x plus 4 times this first fraction, 12x plus 8, divided by negative 5x plus 4. Remember, if you're doing this correctly, those are going to divide out. They're the same. Minus 2 times, and negative minus 2 times this LCD as well. So don't forget to do that. Negative 5x plus 4. All divided by, and do the same thing here. Negative 5x plus 4 times this first fraction, and then negative 5x plus 4 times 3. So negative 5x plus 4 times 15x plus 10, divided by negative 5x plus 4, plus 3 times negative 5x plus 4. Okay? Then these divide out. You're left with 1s as factors. Same thing here, left as 1 as factors. And now what we have, and I know I'm going to need another sheet of paper, so I'm going to go ahead and do that. I know that one's a little bit more tedious, but you do have one on your Alta assignments like that. So that's why I'm going through this. All right, so this is next page. Oops, sorry, from previous page. And that was number problem number 5. Okay, so now we have is this 1 times 12x plus 8 is 12x plus 8, and then let's go ahead and distribute this. A negative 2 times a negative 5x is a positive 10x. A negative 2 times a positive 4 is a negative 8. All divided by, do the same thing here. 1 times 15x plus 10 is 15x plus 10, and then let's distribute the 3. 3 times negative 5x is negative 15x. 3 times 4 is 12. Combining like terms, the 8's cancel out, and the 8 and negative 8 add up to be 0. And in the denominator, the 15 and negative 15x add up to be 0. So you get 12x and 10x is 22x. 10 and 12 is 22. They reduce, and you get x. So therefore, you found that this right here, g of f of x, is equal to x. All right, now step 3, you can say this. Step 3, since f of g of x is equal to x and g of f of x is equal to x, then f of x and g of x are inverses of each other. Okay? All right. Now I do know, and you know, it is very tedious right here, and there are places where if you're not careful you could mess up. But it's very important. It is very important you go through this. You do it again. Go through this and make sure you know algebraically how to manipulate all these expressions. It's very important you do that. So when you get to one little part, don't give up there. You have to force yourself to understand how I'm going from this step to this step, and all that's built on previous knowledge from previous courses as well. Okay, especially when you get to this point and you're simplifying complex fractions, which was from a previous course. Okay? All right, now let's look at one more. All right, so number 6. So you have this square root function here, and you have this quadratic function here. So f of x is the square root of x minus 3, and g of x is x squared plus 3. Now, you learned about inverse. You learned about one-to-one functions. So if a function is one-to-one, then it's going to have an inverse. So in order for a function to have an inverse, it must be one-to-one. And if all you're looking at is this quadratic function, and you saw that in a previous lesson in this course, that this quadratic function is not one-to-one. So that's why we have that restriction right here. Okay? So that's why you see where x is greater than equal to 0. Because I just want to remind you that if you look at the graph of x squared plus 3, g of x, which is x squared plus 3, if you look at that graph, remember that looks like this. 1, 2, 3, the vertex is here, and it looks like this, right? Well, remember, in order for a function to have an inverse, it must be 1 to 1. 1 to 1. Well, this fails a horizontal line test. Fails horizontal line test. So that's one of the things you learned in a lesson. So it fails a horizontal line test. So as it is, g of x does not have an inverse. Okay, but if we restrict the domain, see the domain here is all real numbers. If we restrict the domain, if you restrict the domain to x is greater than equal to 0, we get this graph. 1, 2, 3, and this is the graph that we get. So notice this graph here is the graph of, so this graph is a graph of g of x, which is s squared plus 3, but where we're only using the positive real numbers or 0. All right. So notice that this passes the horizontal line test. So it passes the horizontal line test. So it means it's a one-to-one function, so therefore it has an inverse. So therefore g of x, which equals to x squared plus 3, restricted, will have an inverse. Okay? All right. So you learned about the horizontal line test in the previous lesson, and you learned that a function, in order for a function to have an inverse, it must be 1 to 1. Okay, so that's why you see that restriction right here. All right, but it's not difficult. Let's go ahead and work it out. So if you want to find that those two functions are inverse of each other, it's kind of like that cube root function. Remember that cube root function we had earlier? So it was this one here. If I can find it real quick, let's see. It was this one right here. So if you're able to kind of go through this real easily without any difficulty, then this is just as easy. I just had to tell you though about this domain right here. All right. So that domain was important. It was important that we restrict this function because if we did not, it would not be a one-to-one function. It would not have an inverse. All right, so step 1, find f of g of x. Okay, easy to do, easy to do. G of x is this right here. So it becomes f of x squared plus 3. All right, now I'm going to go to my function f. Remember, this is f of x right here, square root of x minus 3. And in place of that variable that I see, I'm going to substitute that expression. And watch how simple this is. That becomes the square root of x squared plus 3. In the place of that x, I'm substituting this, x squared plus 3. But don't forget, you're subtracting 3. And notice what happens. 3 negative 3 is 0. You get the square root of x squared. And since I restricted the domain, the square root of x squared is going to be x. Since I restricted the domain to just positive, real numbers are 0. I'm going to get x. Okay. Step 2, we're going to find g of f of x. All right, g of f of x. Well, f of x is this right here, is this function. So that becomes g of the square root of x minus 3. Oh, and by the way, so therefore f of g of x is equal to x. Okay, now in place of g, so here was your function g of x. It was x squared plus 3, right? And in place of this variable x right here, I'm going to substitute this right here, the square root of x minus 3. So I get the square root of x minus 3 squared plus 3. The square and the square root onto each other, so you get x minus 3. But you're adding 3, and notice x minus 3 plus 3 is equal to x. So therefore, g of f of x is equal to x. And so since these two are both equal to x, so step 3, since since f of g of x is equal to x and g of f of x is equal to x, then that means f of x and g of x are inverses of each other. And that's it. So I know it was a pretty long lesson, and most of our, well, some of our time was spent on this, was spent on number 5, which was this pretty complicated looking rational expressions, g of x and f of x. But remember, we did have to do a lot of work here. So that's where some of our time was spent was on number 5. But every other problem was fairly simple to do. It's just you remembering that to find if two functions are inverse of each other, you're going to have to find f of g of x, g of f of x, and show that they're both equal to x. And that's it. All right, so that's the end of this lesson.